We started section 10.2, the last teaching class period, I think Monday, and we were talking about displaying data. We had taken a look at several different types of graphs so far. Pictograph was one of them. We did a dot or line plot, and we had done the beginnings of a stem and leaf plot. So we did the first half of this. Well, we did example 3, but this stem and leaf plot extends into another type of plot as well. So if you'll remember on this one, because we're picking back up in the middle of them, the stems on this side, the left-hand side, were the tens place of their grade, and then the leaves were the ones place. So a grade of like 43 was a 4 on the left part of the stem and a 3 on the right part of the stem. And as with every graph, we always need to write a key if it's necessary, and a title all the time. So there is a very nice extension to this called a back-to-back stem and leaf plot. And what these are is 2 stem and leaf plots combined so that they can show a comparison of 2 sets of data. So one of them, instead of just having leaves to the right-hand side like the one we just did, it will actually extend to the left-hand side as well. All right, so we have the same data from last time we're going to come back to in a moment, but this is our second set of data. It's also in your notes, of course. These are the grades from a second exam. So the first one was grades from a first exam. This is grades from a second exam. As teachers, you often like to compare scores of things. This would be for those of you who are, well, that's going to be like all of you at some point, going to be doing student teaching, right? Yeah, and you're going to do this thing called a PPAT that all of the people that you know in student teaching right now are just like in terror of. Y'all know what I'm talking about. My student teacher's in terror of it. She's already done most of it, and she's still in terror of it. But this would be an example of one of the ways to display the data from a pre-test, post-test. Would be a stem and leaf plot, just so you know. So as you're taking a look, what we have over here is actually going to be the exact same thing that I'm going to sort of, if you will, copy and paste. I'm going to rewrite it because I need more of it on there. But it's going to be the right-hand side of the graph, or sorry, the left-hand side of a graph in a moment, and I'm going to reflect it. So taking a look at this new set of data, we're just going to start with this piece, and then we'll combine the last piece with it. So my first thing we're going to do is we're going to actually create the stem and leaf plot for this data first. So if you remember from last time, what we're doing is we're looking for the lowest and the highest values. So somebody tell me what you see as the lowest value on this in this set of data. 64. And the highest value? 99. Is everybody good with that? Okay. So you've got this, you've kind of got some space over here. If you'll notice on your notes, you've got space all over the place. I'm going to have you suggest that you do it in this top right-hand corner beside the problem so that you leave the bottom space for more ability to finish out the problem, okay? So I don't have the space on my screen quite like that, so mine's going to look a little bit different structurally. But we're going to create a stem and leaf plot with the left-hand side having these values that are in the tens place. So you can see the smallest is a 60-something, so I need a 6, 7, 8, and I'll stop at 9 because I've got a 99. So in a moment I'm going to shrink this and move this around, but for now this will be good for being able to see it all. And again, we go through the data and we put them in there. So I've got 93 and 96. So 3 and 6. 98 and 66. So 98 and 66. 67, 82. 92, 85. 64, 81. And you'll notice I'm kind of being sloppy. I'm not worrying about like lining these up because this is not my final one anyway. The final one that I'm going to do is going to put all the leaves in order, and I usually do. You could try to do that on your own to begin with if you wish. I just don't want to mess with trying to be that specific and careful as I'm putting it in there the first time. So I'd rather write it twice. 86 and 72. 96, 95. 99 and 95. 94 and 74. So that's my first time through this. And I'm going to shrink it. All right, so in the larger space that you have at the bottom now, I'd like for you to make 2 vertical lines. And we're going to actually put the stems in between the 2 vertical lines. So comparing the first stem and leaf plot that you did from a couple class periods ago and this stem and leaf plot, we need to have all the stems represented. So what is the smallest stem on either chart? It was a 4, right? So I need this to start at a 4. And where does it need to go up to capture all the data? Up to a 9. So I have 4, 5, 6, 7, 8, and 9. And what I'm going to do is I'm going to use the data that's on my screen for now and get these in order. So I'm going to fill this in on the right-hand side of the stem and leaf plot. And the previous data I'm going to put on the left-hand side. So starting out, this has a 6, a 7, and a 4. So I'm going to put on the row of 6s, I'm going to have 4, 6, 7. And then I have 72, 74, so 2, 4. And now I am being careful to line things up this time. On the 80s row, I have 1, 2, 5, 6. And then on the 90s row, I have a whole bunch. Man, I've got 2, 3, 4. 5, 5. 6, 6, 8, 9, I think. Does that look right? Okay, so you have your paper that's got it all present on here. Mine on my screen is back over here. But I'm going to write these same leaves out, but they're going to be on the left-hand side. So like 43 is going to have the 4 where it is, and then the 3 to the left. And then I'll write a couple more. And then I have 53 and 58, so I've got a 3 and then an 8. But I'm going to do the 3 and then the 8 in this order so that it's extending from the middle backwards instead, okay? So the smaller value, 53, is closer to the 5 and the 8 is further away. And we're going to kind of keep doing that with all the data from the first set of data. So I had a 77, I have 4, 4, 6, 7, I have 0, 2, 7, 7, 8, 9, and I have 0, 0, 4, 4. It's kind of a little bit off. Let's move that down a little bit. All right, so far so good? All right, so our left-hand side is the first exam, our right-hand side is the second exam, and we need to label that, right? We need to put a title on there that shows that information. So this graph is a first and second exam, or our first and second exam scores, or as a first exam, or exam comparison. We'll do comparison, I think. And then I need to put that key in there again, remember? So we'll do it like that, where that double line around the 8 and then a 0 is a score of 80. Again, you can use any value from your chart to represent what the score is. This would be 80. Any questions on that one? Stem and leaf plots are really nice. You can compare things really well from here very quickly. I mean, like super quick once this, at a glance. You can tell me there's a lot more A's on the second exam than the first, right? In fact, all the scores in general are higher on the second exam than the first. You could probably look at the first exam and see it seems like a more what we would call normal distribution if you've done a little bit of statistics somewhere along the way where things kind of occur in sort of a bell shape, you know, where there's some low scores and some high scores, but the majority of the scores are in the middle. It looks more of a normal distribution on the left-hand side, right, the first exam. So there's some different pieces of information. The other thing that this does really nicely, we're going to get to this in section 10.4, where we look for the middle value. The middle value is called the median. Is that this is put everything in order, and you could count it off, and you could find the median from this really well without having to write out every single data value in order, right? Because you could just count them up from where they are. So if you're looking at the second set of data, you could say here's first, second, third, fourth, fifth, sixth, seventh, and you could count up until you meet halfway in the middle to what the middle value is. So there's some really nice things that stem and leaf plots are able to do for us. The next one that we're going to look at is called a grouped frequency table. A grouped frequency table shows how many times data occurs in a range of classes or intervals. So the basic idea with grouped frequency data is that we're creating some sort of classes of information and putting people in, putting people or data values into categories. So the data that we just looked at from our second exam, or even from the first exam, would have been fine. Work kind of nicely with this. In fact, we have a natural sort of way that we do this anyway. We call them letter grades, right? And we say, hey, there's this natural grouping. These people who got this 90 to a 99, 100, whatever you want to call it, but realistically, most people don't get 100, right? They're going to be called the A group. And the people who are in that 80 to 89 group, they're going to be called the B group, right? So we group these things together naturally with grading anyway. So we're going to create a grouped frequency table with the set of data that we just dealt with a moment ago, okay? So the way that this would work is that you have a table, and in your table, you have a category for the grade. We're doing letter grades. And we're going to make the letter grades not written as A, B, C, D, but written with the intervals. So our interval is first, so 60 to 69, 70 to 79, 80 to 89, and 90 to 99. Now notice a few things. We had a natural sort of ordering to this one, right? And we knew that they're 10 pieces apart and all that. I mean, like we have that sort of for free on this problem. If we had used the data that we had seen last class time, where we had Miss Good's class of children, and somebody said to create a grouped frequency distribution, we don't have that natural ordering, right? We would have to create it. We might say, okay, we're just going to draw the mark, if you will, with every group of 3. So like this would be group 1, okay? And then we'd have a group 2, and it's the next 3 values. And then we'd have a group 3, and it's the next 3 values. And then we'd have a group 4, and it's the last 3 values. Okay, but there's nothing in the last one. But something like that, where we would divide it up ourselves into intervals that might have some sort of arbitrariness to them, or we might have been told, create 5 sets of classes. Okay, so you try to make them evenly distributed, that kind of thing. Okay, does that make sense? But they have to be the same width. Like it wouldn't be appropriate for me to put in 4 blue highlighted pieces and 2 red highlighted pieces. That doesn't make any sense. The classes all have to be what we call the same width, the same number of data value, potential values, not number of data points, but the width has to be the same. So in ours, we got that for free. We didn't have to work for that. Our next column is a tally column. And the tally column really just gives us the benefit of marking down where each data value falls. So I go through 93 and 96. So that's 2 in the 90s column. 98, 66, 67, 82, 92, 85, 64, 81, 86, 72, 96, 95, 99, 95, 94, 74, and I'm done. Okay? Because I lose something in this particular distribution. I lose the specificity because I'm grouping things. But in losing the specificity and in grouping them all together, we also gain the sense of there being some consistency within those things, right? Like when somebody looks at your transcripts and sees that you got an A in this math class and somebody else got a C in this math class, right? There should be some sort of sense of what does that mean? right? They grouped together with the people who understood things at this level, and this person's grouped together with people who understood things at this other level. Okay, so that's the tally column. And then your last column here is your frequency column. And all the frequency column is a numerical value, like written out number, for the tally column. Okay, so it's 3, 2, 4, 9. That's it. So again, at a glance, I see, oh, look, there were 3 Ds. Oh, look, there were 9 As. I don't know if the A's were high or low, right? I lost that. But I know there were 9 of them, and I can see that without counting. If I looked at it over here, I would have to count them out, right? So there's some things lost, some things gained by doing it in a grouped frequency. But just like always, we want to label our graph or give it a title. These are grades from a second exam. All right, the next 2 types of graphs that we're going to talk about have some things in common and they have some differences. So let us actually write down the information about histogram, and we're going to write down the information about bar graph, okay? And then I'm going to talk about what's different between them and what's the same. So the first one, a histogram, is made up of adjoining rectangles or bars. The categories are shown along the horizontal axis, and the frequency along the vertical axis. Yes. There's not a key on this one because we don't have any symbols or any notation that needs clarification. Good question. Does everybody have histogram written down? Okay, we'll come back to the question in a minute. Let's do bar graph. I know it's on the next page of your notes. It even says, much like histograms, but they have spaces between the bars to depict categorical data. Okay, so these graphs both look like rectangle bars at heights. That's what they look like. Histograms have bars that touch. Bar graphs have space between them. Okay? There is a natural, like which one would I use in which situation, and it's based on the fact that they're categories. So I'm going to give sort of an unnatural example, but let me give you what naturally works. So what we naturally would do is we would do a histogram where there's data that is continuous, which would be like graded data, right? I mean, I go up in numerical value each 1 point, right? You know, it makes sense for them to be on a continuum. Categorical data would be things that don't make sense to have on a continuum. For example, male versus female. It's not a continuum. Those are 2 separate categories of information. You could even talk about child versus adult. In some sense, there's a continuum there, but usually at a restaurant, they're not caring about that, right? You got to pick one when they say child menu prices, adult menu prices. You don't get it. You don't get a choice, and there's no gray area in between kind of thing going on. So these separating these categories of information. So that's the deal, is that they're really measuring and showing the same thing, but bar graphs are about having categories that are typically disjoint. They're not on a continuum, and histograms are. So I'm going to fabricate this just a little bit with my examples, even though I just told you that that's not really how it generally works. So we're going to do a grouped frequency. This says group frequency. It says use group frequency table. We're going to construct a histogram based on the group frequency table. It's the same set of data. And we're going to draw it for that second exam. So here's what we do. We would draw our vertical axis and our horizontal axis. And we would mark that value of 60 down here, and 70, and 80, and 90. And we would write it down the 100 because we're going in increments of 10, okay? So we need to label what this axis is. These are the grades, or scores, if you will. So I'm just going to write scores. We'll have more we'll have a title here in a minute, but just, this is scores. The vertical axis on either grouped frequency or histogram are both frequency. So the height of each bar that I draw is going to represent an additional person that scored in that value, in that range of values. Okay, now notice on my x-axis, again, evenly spaced apart, or at least pretty close, right? No unrealistic value spacing. We need to do the same thing on our frequency chart, and we need to make sure that our frequency chart represents the values we have. So you notice we have 2, 3, 4, and 9. So I'm going to just draw a hash mark from the numbers from 1 to 10. Okay? And just like with one of the ones we had done before, you don't have to label every hash mark. So if it makes more sense to label every other one or every fifth one, given your data, that's totally fine. I think I'm going to label every other just so I don't have too many numbers going on here. So here's 2, 4, 6. I have 8. And then I know I won't have a 10, but there's 10 up there at the top. Here's where the technology that I have up here is just beautifully done, so watch this. Okay, so the first bar chart that we have, our first bar that we have, should have a height of 3, right? There were 3 people that actually got that value, a score in the 60s. I'm going to use it thinner, and I'll do that differently. So here's a bar height of 3. The next one had a frequency of 2, so now I need a bar that's a height of 2. And then I had a height of 4. And my last one has a height of 9. Okay, and you don't have to shade them in, but they look nicer if I shade them in, so I'm going to shade mine in. Okay, so here are the heights that I have. I've got the axes labeled. The only other thing I need is I need a title for the graph. So these are grades. From a second exam. So if I were wanting to do a bar graph with the same data, the only difference with this set of data is that I would make space between the bars, number 1, and on the axis at the bottom, instead of labeling the numerical values, I would label them with A, B, C, and D, because those are the categories that I created. Does that make sense? So we're going to do the same thing now with this other set of data. It's the same set of data, but with this other graph. And we're going to try and do it the way that it would be done for a bar graph instead of for a histogram. So much of the pieces are the same. This is frequency. I'll write grade at the bottom instead of score because it makes more sense when you're talking about the letter grade, right? If you write score, it's probably fine. I mean, it is fine, but... And I'm going to mark the frequencies the same way I did before. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and label every other one. So the first one is a bar of height 3. And then I need a bar of height 2. And the bars should have the same width, approximately, and there should be space between them. And then I need a bar of height 4. And then I need a bar of height 9. Again, approximately the same width. And if I shade them in just for visual referencing. And then underneath, I would label the letter grades. This is D, C, B, and A. And my title would be the same as the title before. I'm just going to call it letter grades now specifically because that's the type of grade at this point I have. Letter grades on a second exam. If you don't include the word letter, it's fine. It's okay? So the purpose really in a bar graph is for categorical data that doesn't have this sort of continuum like male, female. Okay. A double bar graph, much like a back-to-back stem and leaf plot, can be used to make comparisons in data, but from a more visual perspective, right? Instead of the numerical perspective of that back-to-back stem and leaf plot. So if we use the data from the back-to-back stem and leaf plot, which is what we're going to do, we're going to create a double bar graph. And that's example 8. So this graph, as you'll know, you've got lots of space there at the bottom of your page because you need lots of space to do this. If you do have some colors with you, highlighters, colored pencils, or crayons, or something like that, it might be helpful to do with this one. If we go back to our back-to-back stem and leaf plot, this would be a really good example for a place where this really is a bar graph instead of being a histogram. A histogram really has categories of equal width, right? I talked about that. But if you take a look at the particular data we're dealing with, we would say that all of these, whoops, I meant to do a highlighter, all of these grades would be failing grades, right? They're an F. But they spread across more than a 10 width. They're actually across a 20 width here if we wanted to think about that. We have grades in the 40s and in the 50s. So what we're going to do, since we're doing the double, because it is a double bar graph we're doing, it doesn't matter. We've created a category, and the category says that this is a letter grade of F. Okay? If we were actually doing a histogram, we'd have a problem with that, and we'd have to have a 40s column and a 50s column, and we'd have to separate them out. But we're doing a bar chart in categorical data. So let's see. I've got 2 Fs. I have 1 D. I have 4 Cs, 6 Bs, and 4 As. Those are the values that I need to do. So if on your paper, as you're looking back and forth, you're flipping back and forth between this one and over here where we're about to draw our picture. So we have category for the letter F, right? And a letter grade of F. And on the first, actually, let me get my frequencies marked again. All right. So there's 10 of them, and I'll label every other one again. Okay, so on the first one, I have 4 students, right, who got Fs on the first test. But there's nobody who got an F on the second test, right? So I need to leave a blank space that's a wide enough space that says that, hey, a bar is missing here. Are you with me? So my next bar that I'm going to do for exam number 1, that is the letter D, had how many on it? I think it was it 1? Is there 1D? So I've got a space that I'm missing, and then I'm drawing another one right here. Has a height of 1. It's a little high. Is it 1? Y'all are whispering like maybe I'm not right. Is it 1? And then what is the number of D's on the second test? There are 3. So I'm going to choose a different color here. And I've got 3 D's on the second test. So you'll notice I have, basically, I'm going to draw it in and I'll erase it. There's a bar missing here because there were no F's on exam number 1. I'll label my axis here in a minute. Then I have exam number 1, and I have the C's. How many C's were there on exam number 1? 4. So I need a height of 4 again. And how many C's are there on exam number 2? There are 2. Like so. How many B's are on exam number 1? 6. And how many B's on exam number 2? I'm sorry, what was it? 4, okay. Okay, and then how many A's were there on exam number 1? 4. And how many A's are on exam number 2? A whole bunch, right? 9. So, extend this just a little bit. So these bars, they touch, but they only touch when they're the same letter grade, right? So like A's don't touch B's, so to speak, but the A's for exam 1 and exam 2 touch each other. So here are my A's, here are my B's, my C's, my D's, and my F's. And yes, there is a space missing because there were no F's on exam number 2.
On exam number 1, weren't there only 3 F's?
I don't know, maybe there were 3. I was just going off what I remembered. Yep, there are. We'll fix it. Thank you. All right, and I'm going to fill them in. Okay, so the colors are really helpful for this because we're actually going to need to distinguish what's going on when we write our title. So exam 1 are the red bars, exam 2 are the blue bars, right? All right, and my labels are much the same. These are letter grades. Or you could just say grades if you wish, and this is frequency. And we're going to label on here that these are the first and second exam. Comparison. Where the red, on my case, is the first exam. And the blue is the second exam. Any questions on that one? Okay, so an apology to make right now real quick. I meant to grab compasses from Dr. Marsh, and I forgot to. Actually, protractors was what I meant to say the first time I was right. Protractors from Dr. Marsh, and I forgot to. She has them for her geometry class, and I need them for this one piece in prop and stat, and I forgot. So here's what we're going to do. We're going to stop. We're going to do your group work. All that's going to start. We're not starting 10-3. But the parts that talk about pie charts or circle graphs, just leave a space for them in your homework, and we'll come back to them and we'll finish up those pieces on Monday, okay? So, and when I say a space for them, these take up a good chunk of space. So, I mean, you're looking at probably a third of a page that you're going to leave when it talks about actually creating a graph for one. If it's talking about just answering a question about one, you can leave just a few lines. But I'd talk like a third of a page if it's asking you to create a picture for one, okay? So we will finish the pie chart circle graph stuff on Monday.